At IIT ISM. Here where we are standing, it is just beside the health center, and it is basically to demonstrate you that how in the underground Longwall gallery operated. Because Longwall coal mining method is a method that is fully mechanized. Machines operated and on very less manpower is required, so its productivity is very high, and that require high mechanization and high different type of machine is required. We have a same prototype machines support system, because in underground you can easily imagine that when you are entering to an underground tunnel or underground drivage, you need to support that roof because men are moving in the gallery. So you need to support that roof with a support system. So we have the real support system installed here. So we will visit one after another to see there is a gallery, there is a drivage road, then there is a main face, how it's actually operates in real underground Longwall mine. Okay, so it is our facility. So I will lead you to the main face and I will introduce you different machines, what are the machines, what they do really in the field, so that you can get an acquainted with the mining environment in the underground. Okay, let's move. This is motors. This is motors.
This will be a conveyor system actually.
So
Yes, you can see this is a Longwall conveyor system.
you see the transport system. After production is going on, coal is cut through, and this belt conveyor is moving continuously. So coal fall on the belt conveyor and it transported directly to the surface. So there is no intervention of man. It's a continuous process and continuous extraction going on, and it is lifted to the surface.
Once coal is cut by the shearer, directly coal will be loaded on this.
Yes.
Directly. So from this directly transported to the surface. And this will be the complete conveyor system. In the real field. These, hope you have seen any videos of Longwall mining. Many of mining engineers of civil.
So they might not have seen.
Okay, you might not. This will be the complete picture or complete scenario how a Longwall mine looks like. This you can see that this is like a power supply. This one phase will be like it is a made in a very short form, but in underground mine it will be a very big. So these are the number of.
You will introduce the machine, but before that I will introduce the geometry, how it looks like. Actually, in Longwall we are attacking the coal seam with a long lane at one go. So what we do basically, suppose this is a coal seam, and generally coal seam have some amount of gradient. So suppose this is the coal seam. Now we started from the bottom end. We coming through the gallery. This is a road. We have come to here now. Now we want to advance this way and cut all the coal with that coal cutter. It's not coal cutter, it is the name. It is shearer. It's a shearer. There's a dart, sard, single-ended shearer, double-ended ranging shearer. So it will give, here rock mechanic is needed. It will give a thrust force on the rock. It will give a thrust force like this, then it will rotate. So what will happen? A thrust force, then it will rotate, so coal will be loosened. The rock will be weakened. So with that, it will fall on this conveyor. So in this conveyor also moving, and that will transport to the main conveyor, and that will transport the coal to the surface. So mechanics is this Longwall gallery, there is no drilling blasting, no explosive, only by shards. This shards is also chain mounted. It is moving. After cutting coal, this side completed. Then again it will go that side. Again that will go come this side. So generally we address 100 meter, 150 meter at one go. So the mechanism is giving a thrust, then rotate, then rock will fall on this conveyor and it will be transported. Now, when you are cutting the coal, you are advancing. So the roof will come, roof will sag. So to support that roof, this is the power support system. There is a power support system. You can see here 6 leg power support. There is 1 leg, 2 leg, 3, 4, 5, 6 legs. Or it is 6 legs or 4 legs? 6 legs. Nowadays modern is 2. 4 is also common. So this 4 leg basically hydraulically operated. So that hydraulic chamber you have seen, it is being prepared with water and some oil kind of material to prepare that hydraulic pressure, and depending upon the necessary of the overburden roof and unsupported roof, it will take the support and it will give that amount of pressure to support the roof. Okay. So mechanics wise, there this kind of support system. Suppose 100 meter is my length, 100 meter my length of the face, and the width of this power support is 1 meter. Then 100 number of this power support to be installed side by side to completely support the roof system, and it is going on. So this is basically the mechanics. And many things are left. Mr. Sai will explain you the rest.
Yes, most of the code is we understood that this is the power support. This will be used for the support system. Okay, in underground mine we don't follow any we follow some other support systems also, but main sole part of their longwall mining will be the power supports. So major part will be supporting system will be supported by this power supports only. There will be different type of legs, 4 leg system, 6 leg system, and number of leg system depending on the strata condition. If once the strata is very poor or it needs much capable conditions, we will go for a much longer leg support systems which have in more ton capacity, which holds much tonnage capacity. Okay, based on that, once the advancement is going on, as soon as advance is going on, support system will be also getting to advance. As soon as, for example, if we are at this phase, this is a shearer. You can see shearer. You can see directly. This is a Longwall shearer, cutting shearer. Okay.
This is a real shearer.
This is a real shearer, where you can see that cutting picks and all. If you suppose consider this block as a cold block, when your machine is operated, this shearer will directly cut the block. You hope you know that how the cycling process will be. It is completely cutting down the coal and it will be advancing to the face. As soon as it is advancing, we all know that roof will sag immediately. When any extraction is taking place, roof will completely sag immediately. So in order to protect ourselves or mining engineers or whatever that environment, we follow this power system. This power system enhances that roof sagging and it helps us to stay in a safe place. Okay, so this is the more sole part of our longwall mining will be the power support system and the shearer system. Once the shearer cuts the coal, automatically the cut on the coal will be loaded onto the conveyor system and it will be directly transported to the surface. So this will be the more sole process.
This is called armor face conveyor.
AFC.
There are different type of conveyor you will get in mining. This is basically called AFC, armor face conveyor, because this conveyor is laid in the face and it is armored.
And this is mostly used in longwall mines.
So this is as a geomechanical problem, geomechanical risk, as in the syllabus you have already been taught. We need to consider what type of leg system we will use depending upon at what depth we will work, and what is the strata condition and what is the gradient. And if it is 4-legged or 2-legged, that is depends. And how much hydraulic pressure I am going to generate with this system possible. So based on that, based on the mine condition, this whole power support system as well as SARTs is customized and produced in a factory. It is not just like it is marketed in the market just like you purchase. No. Based upon the mining requirement, mining engineers along with the geomechanical engineers, they design which kind of support system is need to be required, and for depending upon the coal hardness and toughness, which kind of shearer will be used, what will be the capacity, and to substantiate and complement all this effort, which type of support system need to be developed for this kind of strata condition, all are customized and then produced. So that is why this kind of mining is a very capital intensive mining. Once it is performed well, then it will give a very good run. Very good run and very safe mining. This mining is very safe. See, because when production is going on normally, people have to travel all along this. They have to travel. So people are not traveling in an unsafe route. See, up the helmet or up the head, they have this supported room one after another. So they are working under a very safe condition. Okay, so this is the beauty of the Longwall, and in particularly if I talk about the success of this kind of mining methods, China have achieved a very good success in this kind of mining. Though in India, 2-3 mines we are running very successfully, but majority of the Indian cases we could not implement this kind of methods. But we have very good mechanized Longwall face in Jhajra, 1 or 2 in Singareni Coalfield Limited, they are also operating very good. So accepting that, we are not in a position, means we have a very few Longwall face now in India. But China is now a giant leader in this kind of mining methodology, and they are producing maximum coal through underground Longwall mining methods.
It is due to cost effective.
One more point.
It's very mechanized, highly mechanized and very safe.
One more point is that for lacking of the success in Longwall mines, our Indian coal seams are very possible that we don't have a complete free coal seams. We have coal seams that is involved with faults and dead bands. Since the Longwall is a very highly capital involved system, we cannot once it is a continuous process. We can't stop the production in middle. For 1 day production, it costs very huge. If we stop a production for 1 day, it will cost very huge capital loss for the management. So since we encounter any band, if suppose there is a coals in this, and if we encounter any band fault or anything, we can't continue the process. Unless we have to shift the complete equipment to the after continuing the fault. So until that, it will be called as a salvaging period. Where the salvaging period, that time of period is called as a salvaging period, where we shift our complete equipment, or when the complete extraction is completed, when we go to other panel, or where in middle of the panel if we encounter any faults or any joints where we can't continue our extraction. So at that point we face very loss, because we cannot continue the process. This shearer is completely made to cut the coal, only coal. It cannot cut any rock type of materials. So once we encounter any fault, it is very not possible to continue the production. So it is one of the lacking point that why India is not at all not completely successful in longwall mining. And since we have 3 successful longwall mining in India, one is Singareni ALP, Adriana Longwall project, and second is Janjra ECL, and one more is Munidi ECL, where 3 successful longwall minings are being successfully practiced right now in India. And coming to this leg point, we already discussed that this is for the power support. One more point is that when we are going according to strata condition, it plays a key role. This leg points and all, leg pressure and all. When we are going for underground strata, we have initially mining engineers initially have to analyze the what amount of this pressure will be acting on the roof. So based on that pressure, we will be setting up the leg pressures. Or if suppose 500 tons of weight may be expected based on the geological condition, so we will set up the pressure to the 500 tons. So if it is not at all set up at a 500 tons pressure, if suppose 500 tons pressure is acting, but its setup is only at 400 tons, then the failure of power support may happen. So what is the main critical things that mining engineers should analyze is that mining engineers should initially analyze the amount of the stress or the overburden that will affect, or pressure that will act on the strata. So based on that, we will put up the pressure conditions over here. Okay.
That is very necessary, and for that rock mechanics engineer is very necessary to be in the team to design this kind of something, longwall gallery. Please.
Yeah. So it is very successful in other countries, because UK and China, they are very successful because their seams are very different from the Indian geomining condition. Their seams are very free from the bands, falls and all like that.
Means geological discontinuity.
Geological discontinuity. Once this longwall mining is in a single point, we can say that this longwall mining is very restricted, where the coal seam is very free from the geological disturbances. Once the coal seam is free from the geological disturbance, we can continue the process and we can go on. But in Indian geomining conditions, as you know that all the coal seams will encounter some sort of faults or dead bands in between the coal seams. That is the lacking point in our geomining conditions. And Another system is that, as you know, that continuous method will be the leading in mechanized, even fault sales.
This is fully mechanized phase.
Fully mechanized. This and continuous method are the most undergone methods.
So if you have any question, you can ask. See, this is the structure of the power support. This is kind of leg. Leg is giving a thrust, and root is.
Pressure will be acting on this exactly. Okay, so that when we set up a particular pressure, it will hold the pressure. If we set up at a pressure of 500 tons or whatever, if that level of pressure is acting on it, it can hold it up. So mining engineers or whoever employed in this particular phase, they will be in a safe environment.
Because suppose you are working in a 400 meter depth. You imagine 400 meter top, there is a city, there are a lot of things. So there is some psychological problem here. But this power support is to help you. They will take whole lot of load and it will maintain the roof without any depression. It is iron. It is iron. Iron with some amount of alloy. It's a steel basically. So once 1 meter is advanced, all setup has to be advanced. Yes. So this power support has to be advanced. So it is a continuous process.
And what the support for the roof support for frame?
Yes, it will be lowered, it will be advanced, then it will be up.
The friction which is already exposed.
So I will allow to fall. So coal, our main purpose is to produce coal. So that coal is being cut and being transported. So rest of the things is we are allowed to fall.
Once we move this forward, what about the portion that is already excavated? What about the roof support for that?
That is in the scope. That is I allowed to fall. Another is condition that the Longwall will succeed. Your roof should be very competent. That it is capable. It is capable. Means after progression of the Longwall gallery, means this power support and the shearer, the back end, that is a go page where already coal is extracted, that should fall. That should automatically cave. So that if do not cave, then huge amount of abutment pressure will develop. That may damage this whole kind of support system. So that is very important question, that what will happen. Generally what we expect mechanically, we generally predict that there will be amount of failure. That is why before mining we generally test physico-mechanical properties of the rock and its capable properties in a laboratory. If it is capable, then only we go for large capital intensive this kind of mining methods. If not, then we have to think about other mining methods.
Point is that Longwall is a very successful method and very high. Undoubtedly, in underground mining, Longwall is the best method for production wise. We can achieve more than 90% with the Longwall method. The point is that Longwall method is very restricted to some sort of conditions. It cannot be implemented in all mining conditions, all geomining conditions. Okay, this method is completely applicable to a fixed geomining conditions where such as coal seam should be free from the dead bands or any faults sort of things. And one more thing is that capability of the seam also will be the most important. Roof capability of the roof will be also most important. So some sort of things and some other points like capability, and it ensures that production wise we have to include all these points. We cannot if a seam is having some force, we cannot implement directly this Longwall method. It cannot be successful. If seam is completely weakable, if seam is completely weak or completely capable, if it within while extraction itself it is capable, at that point of time also we cannot implement Longwall mining. Are you getting? So weak should not be completely competent enough. I mean uncapable, or it should not be completely weak. It should be a competent roof until it should bear the strata until the extraction. Once the extraction is done, then we allow the roof to cave. Okay, it should not cave before early, and it should not cave, and after the extraction it should not be like a go fetch. Okay, go fetch matlab we should allow it to cave. If it is not caveable, then it is completely go, yes or no? So it will be a very dangerous situation where we encounter any coal any explosion sort of things go is a very dangerous explosion, coal dust explosion or air dust explosion, it may happen. So we have to ensure that coal seam should be free from the any faults, joints or whatever things. Seam should be free from all these things. And second thing is that key seam should be a competent, roof should be a competent roof. Okay, it has some restrictions. Longwall is completely restriction. That's why in complete, even though we have nearly 286 underground coal mines in India, we have only 3 mines that is being followed Longwall mining. Even though we have 286 underground coal mines, we have only 3 mines that is implemented Longwall mining because it has its own restrictions to get involved.
So if this site of coal is to taken over, then if you want to go to deeper section, then
So there is also restriction that Longwall cannot extract 2 meter, 3 meter, up to 3 meter seam. It can address at one go. If the seam thickness is more than that, then a large amount.
Point is that, sir, if seam is around more than 4.8 or like that, we possibly try to extract in the center point initially, and then we try to move in a down floor part to be extracted, but roof part mostly allowed.
So there is also restriction that based on the seam thickness, the suitability of the long wall depends.
Yeah, shearer size of the should be maintained.
Yes, shearer size.
Because it should cut the coal accordingly.
Yes, that is prospecting and preparation of the detailed project report.
by boring also.
Yes, yes, there are many mining institutions, they do it, and they also hire time to time the expert what should be the action plan. So we are actually standing just like a mining situation. So if you have any question, you can ask. Else we will move. So here, movement of the coal production This production system, so these are installed in the gate and box. So these are called the gate and box, where different electrical instruments, machines, switchboard are installed. Because it's a continuous process is going on, so that is why these are also to be shifted accordingly. And through this gallery, ventilation is maintained. Through this gallery, ventilation is maintained. It's a complete, ultimately when you are in the phase, it's a all mechanical phenomenon. It's a mechanical phenomenon. Machine interacts with the phase, they cut coal, transport to the AFC, then the conveyor, then it's go, then again shift the machine to advance the next phase, and that will accordingly the power supply. No, man is there, but manpower requirement is very less. It's a very, very high productive mining system. Very, very high productive. Today, the state election of the Jharkhand, they are all given the duties to training, application. No one is available. So what I know, I try to explain. Some question arrive, you can see here is our friend is also available. He will speak and also because his entire work is going to be underground mining. Okay, let's move.